Humankind has done so for a very long time, gazed into the endless darkness of the night sky, filled with awe and wonder about the many unexplained secrets that lie beyond our world. In the 1900s, a theory proposed by scientists, the Big Bang, to describe how the universe came into existence, developed, and why it keeps growing. Although this theory gained widespread support, it still fails to provide answers to some of the most basic questions about the cosmos. In recent times, groundbreaking discoveries have made it even harder to solve these mysteries. In 2023, such a moment emerged when NASA's James Webb Space Telescope discovered objects in the sky that appeared to date back further than the universe. This revelation by itself shocked scientists and ignited a heated debate. Could it really be possible for stars to exist longer than the very universe they inhabit? The discovery of the Webb has presented challenges to the current understanding of space and time, raising the possibility that our entire model of the cosmos may need a fundamental overhaul. These types of baffling inquiries are exactly what we'll be digging into. If you're captivated by the universe and have a desire to stay in the loop with new discoveries, be sure to subscribe, hit the like button, and turn on the notification bell so you never miss a beat. Approximately 200 years in a constellation far from Earth, known as Apis, lies a particularly fascinating star known as HD 14-83. What makes this star so captivating isn't just its rate of travel blistering 4,483 kilometers per second, but the story hidden in its past. Around 1 billion years ago, during the early formation of the Milky Way, our galaxy collided with a much smaller one, and this star was one of the surviving members of that cosmic crash. But what actually sets HD 14-83 apart isn't its journey or speed, it's its age. Nicknamed Methuselah after the biblical figure, legend has it that this star was around for nearly 1,000 years. It is regarded as one of the earliest ever observed. Initial calculations put its age at an astonishing 16 billion years. This has been refined by more recent estimates to about 14.46 billion years, with an uncertainty of 800 million years. This still puts it older than what was thought. The 13.8 billion year age of the universe, as calculated using data from the cosmic microwave background radiation. This leads to a puzzling contradiction. How can a star be older than the universe that contains it? This apparent inconsistency has forced scientists to reconsider how we determine the ages of stars and the cosmos, driving deeper inquiry into these confounding astronomical riddles. To fully grasp this paradox, we have to appreciate the difficulties in estimating the age of stars. Stars like our Sun remain fairly consistent in size and temperature over extremely long periods, making it incredibly challenging to determine their age with precision. Astronomers must monitor tiny changes in a star's light and hue and contrast them with complex models of stellar evolution. One of the most important methods is gyrochronology, which involves analyzing how fast a star spins. Just like a top that spins but slows down over time, stars gradually lose their rotation speed. By evaluating this decrease and comparing it to known-age stars, scientists can use mathematical models to calculate Methuselah's age. Unquestionably ancient, and by current measures, it stands as the oldest star we know. But rather than focusing on whether it might be older than the universe, perhaps we should flip the question: could our universe actually be older than formerly calculated? Efforts to imagine that 13.8 billion years are not an impossible task. Imagine compressing everything cosmic history into a single year, where the Big Bang happens at midnight on January 1st. Earth wouldn't appear until the final hours of December 31st, and the entire span of human civilization would fill only the final few seconds of that fictitious year. Astronomers have determined the universe's age by studying light from incredibly distant stars formed shortly after the Big Bang and factoring in redshift, an effect caused by the stretching of light as the universe grows. This data leads to the current estimate of 13.8 billion years, but a recent proposal from the University of Ottawa suggests this might be an underestimate. The theory claims the universe could actually be around 26.7 billion years old. This daring idea was introduced by Rajendra Gupta, a physicist who revisited a theory from 1929 by Swiss astronomer Fritz Zwicky and paired it with more recent insights. Gupta suggests that over vast intervals of time and distance, protons lose energy, a notion that runs counter to how we currently interpret redshift. Instead of attributing redshift solely to cosmic expansion, Gupta believes it might be a combination of factors. If true, this hybrid explanation could completely alter our understanding of how old the universe really is, potentially resolving several long-standing debates, many of which have come to light thanks to recent findings from NASA's space telescopes. Gupta's theory builds upon the old idea of light and introduces something called evolutionary interaction constants, originally suggested by theoretical physicist Paul Dirac, who suggested that the character of cosmic forces evolved over time. It's worth remembering that our ideas about the universe's age have significantly changed. In the 1920s, Edwin Hubble estimated the universe's age to be around 2 billion years. Over the decades, more accurate observations have raised that number to reflect the currently agreed-upon 13.8 billion. Whether we think of human history as a few seconds or milliseconds on the vast cosmic clock, there's no denying that the universe is beyond comprehension, and its ongoing expansion constantly challenges our previous assumptions. In the interim, scientists are making fascinating observations about our own Milky Way. For example, recent data has shown that stars on the outer edges of our galaxy move much more slowly than those in other galaxies. One theory is that there is less dark matter in the Milky Way than we thought. Dark matter, though invisible, plays a major role in how gravity behaves on a cosmic scale. There is also the possibility that the comprehension of the nature of dark matter distributed across the universe is erroneous. This mystery stems from data gathered by the European Space Agency's Gaia mission, which has mapped almost 2 billion stars in our galaxy. As a result of these findings, rethinking the way stars behave, especially at the fringes of the Milky Way, is necessary. The rate at which stars move in space is directly tied to the galaxy's total mass. Gravity's grip depends on how much matter, both visible and invisible, is present. A recent analysis using Gaia's data suggests that the Milky Way's mass, including gas, dust, stars, and dark matter, may be approximately 200,000 billion times the mass of our Sun, equal to 5 times lower than previous estimates. This drastic reduction may indicate a surprising lack of dark matter. Still, it is extremely difficult to calculate a galaxy's mass. Complications and ambiguity in the satellite data or in the analytical models used may skew the results. As we assemble more precise data and develop better instruments, we'll keep tracking these developments. Looking ahead, future technological advances and space missions will likely illuminate many of these unresolved cosmic puzzles. The James Webb Space Telescope, with its unrivaled power, is pushing the boundaries of science in ways never seen before. Its mission goes far beyond estimating the epochs of stars or the universe as a whole. It's also revealing the inner workings, the bizarre properties of galaxies, dark matter, and the unseen forces shaping the cosmic evolution of the universe. The expansion of the universe is still a central mystery, but as new information comes in, we might discover that our cherished assumptions were either incorrect or incomplete. A critical question remains: do the laws of physics we rely on work the same way across all scales, locations, and ages of the universe? Could there be hidden forces or unknown phenomena that affect how galaxies behave and how stars age? As our instruments become sharper and more capable, we may stumble upon breakthroughs that shake the foundations of modern science. Experts are beginning to realize that we're only scratching the surface when it comes to understanding dark matter, dark energy, and the fundamental interactions that control the universe. For each new observation, From ancient stars to faraway galaxies, the remains provide clues about how the universe functions, but these clues often generate more questions than answers, pushing the edges of human knowledge. The ever-increasing likelihood that stars could have existed prior to the universe, or that the universe itself is much older than we thought, forces a total rethinking of modern cosmology. It suggests that new theories, brand new physics, and possibly a totally different way of looking through the layers of space and time may be needed. These changes affect more than just scientific models. They target the core of philosophical inquiries regarding reality and our place within it. If these discoveries are established, they could completely transform what we think we know about existence itself. As debates about the universe's true age rage on, it is becoming increasingly apparent that we're entering a new chapter in cosmic investigation. What the coming decades might bring is clarity to questions that have puzzled thinkers for thousands of years. Whether it's finding stars older than the known universe or resolving the puzzles of dark matter and energy, the universe continues to hide truths just waiting to be revealed. The next step is all about questioning, testing, and refining our understanding of everything that lies beyond our tiny blue planet. Even though we don't yet have all the answers, the pursuit of knowledge is just getting started. So, keep in touch for more updates on these incredible revelations and new theories. Maintain your curiosity because the future may uncover astonishing breakthroughs we can't yet imagine. If you're passionate about space science and wish to stay informed, subscribe to our channel, hit that like button, and switch on the alert bell to ensure you never miss an important update. As we journey deeper into the universe's depths, we stand on the brink of game-changing discoveries. The James Webb Space Telescope has already delivered mesmerizing images and data about remote planets, faraway galaxies, and other marvels of the heavens, but this is only the beginning. As it continues its mission, Webb may reveal information that completely rethinks our understanding of how the cosmos works. Among the most exciting aspects of this investigation is the ongoing search for alien worlds that could harbor life. With a growing number of exoplanets discovered in the so-called habitable zone, the concept of life beyond Earth is more plausible than ever. Even the detection of simple microbes on another planet would change biology forever and rewrite our theories of evolution and our place in the universe. The investigation into the mysterious forces of dark energy and dark matter will challenge and expand the boundaries of physics as we know it. These unseen forces make up most of the mass and energy of the universe, but we still have very little understanding of how they function. Solving these puzzles could open up completely new layers of reality. Simultaneously, astronomers are continuing research into the behavior of galaxies. For instance, the unexpected discovery that stars in the Milky Way's outskirts are moving slower than expected has already forced a re-evaluation of existing models of the galaxy's dynamics. This could mean that the Milky Way, and possibly other galaxies, has less dark matter than previously thought, which could reshape how we understand gravity and the universe's structure. This is a perfect illustration of how new evidence can force dramatic changes in long-standing scientific beliefs. The idea that galaxies evolve in ways we haven't yet fully grasped underlines the need for a more advanced strategy to study the universe. Could the cosmos be far older than our current models indicate? Are there elements of its story we've barely begun to uncover? Astronomers will keep chasing these big questions as more information arrives from present and future missions. With every breakthrough, it's clearer than ever that our current comprehension is merely the beginning. There is still much to explore, and the more we discover, the more we comprehend how much is still unknown. This never-ending drive to discover the truth and ask deeper questions is what powers the human spirit of scientific discovery.